Imagine looking up at the night sky. You see countless stars, each one a distant sun. Some of these suns might have planets orbiting them, just like our own Earth. Now, what if something out there was trying to send us a message? What if, across the vast, silent emptiness of space, a signal was traveling towards us? This isn't just a fantasy from a science fiction story. It's a real question that astronomers are asking themselves today. They are trying to understand some of the most powerful and puzzling signals ever detected from deep space. These signals are like cosmic whispers, brief but incredibly strong, and we don't yet know who or what is sending them. These mysterious signals are called fast radio bursts, or FRBs for short. Think of them as a sudden, intense flash of light, but instead of light we can see, it's a burst of radio waves. This flash lasts for only a tiny fraction of a second, much quicker than the blink of an eye. Yet in that fleeting moment it can release more energy than our sun does in an entire day. The story of fast radio bursts begins by complete accident. In 2007, an astronomer named Duncan Lorimer was looking through old data from the Parkes Radio Telescope in Australia. Suddenly, they stumbled upon something extraordinary in the data. It was a single, incredibly bright burst of radio waves that lasted for less than 5 milliseconds. For several years, many scientists were skeptical. They thought it might be interference from something on Earth, perhaps even a microwave oven in the observatory's kitchen. For 6 long years after the 2007 announcement, the Lorimer burst stood alone. The silence was deafening. Then in 2013, the silence was broken. A team using the same Parkes telescope confirmed the detection of 4 more bursts. This was the turning point. With this confirmation, the floodgates opened. Observatories around the world joined the hunt, and as telescope technology improved, the number of discoveries began to grow rapidly. In 2015, a new mystery emerged. Researchers using the Reusable Observatory were studying an FRB that had been discovered earlier, named FRB 121102. Unlike all the others found up to that point, this one did something extraordinary. It flashed again, and again, and again. They had discovered the first repeater, a source that sent out multiple bursts from the exact same spot in the distant cosmos. This was a game-changing discovery. It immediately split the FRB population into 2 apparent classes, the one-off cataclysmic events and the repeating sources. A burst that happens only once could be explained by a violent, self-destructive event, like 2 neutron stars colliding. But a repeating FRB had to come from something that could survive the immense energy release and live to flash another day. Over the following months and years, hundreds of bursts were detected from this single source. This allowed scientists to pinpoint its location with incredible precision. They traced it back to a tiny, faint dwarf galaxy, over 3 billion light-years away. For the first time, we knew the home address of an FRB. This breakthrough brought both answers and more questions. To understand what might be causing fast radio bursts, we have to journey into the most extreme environments the universe has to offer. When a star much more massive than our sun runs out of fuel, it collapses under its own immense gravity and then explodes in a brilliant flash called a supernova. What's left behind is one of the universe's most bizarre creations, a neutron star. Imagine taking a star 1.5 times the mass of our sun and crushing it down into a ball no bigger than a city. Among the family of neutron stars, there is a particularly wild and unruly cousin, the magnetar. It is a special type of young neutron star with a magnetic field that is unimaginably strong, about 1,000 times stronger than that of a normal neutron star. Eventually, this stress becomes too much to bear, and the crust suddenly cracks and rearranges itself. This event is known as a starquake, releasing a huge amount of energy in a very short time. In 2020, this theory received a huge boost. For the first time, astronomers detected a fast radio burst that came from inside our own Milky Way galaxy. They were able to trace this burst directly to a known magnetar in our galactic backyard. It was the first time an FRB had been linked to a specific object, providing a smoking gun for the magnetar theory. So far we have explored the natural, albeit violent, explanations for fast radio bursts. These theories are powerful and supported by a growing body of evidence. And yet, there is another possibility, one that is far more speculative but also, honestly, infinitely more exciting. What if these signals are not natural at all? What if they are artificial? What if they are messages from an extraterrestrial intelligence? The suggestion that FRBs could be alien technology is highly controversial in the scientific community, and for good reason. Before we can claim to have discovered alien life, we must exhaust every possible natural explanation. Despite this necessary caution, a few prominent scientists have argued that the alien hypothesis should not be dismissed out of hand. Professor Avi Loeb of Harvard University has famously urged his colleagues to consider the possibility more seriously. One of the most compelling ideas is that they are not messages intended for communication, but rather beacons. Think of them as a galactic lighthouse, sweeping a powerful beam of light across space to announce, "We are here." The energy requirements for such a project are immense, far beyond anything humanity could currently achieve. But we are talking about a civilization that could be thousands or even millions of years more advanced than our own. We stand at a fascinating crossroads in our quest to understand fast radio bursts. On one side, we have the camp of natural explanations, grounded in the solid, if extreme, physics of our universe. When we weigh the evidence, the scale currently tips heavily in favor of natural explanations. The most powerful piece of evidence is FRB 200428, the burst detected from within our own Milky Way. However, the evidence is not as conclusive as it might seem. The burst from the Milky Way magnetar was thousands of times less energetic than the FRBs we see from other galaxies. The repeating source, FRB 180916, for example, flashes in a surprisingly regular 16.35-day cycle. While a natural cause could explain this, it also looks tantalizingly like the deliberate schedule of a beacon. The last few years have marked a golden age for FRB research, driven largely by the arrival of a new generation of powerful radio telescopes. A prime example is the Canadian Hydrogen Intensity Mapping Experiment, or CHIME. Since it began operating in 2018, it has detected over 1,000 fast radio bursts, dramatically increasing the total number known to science. Alongside CHIME, other powerful instruments around the world are joining the hunt. Together, these new telescopes are creating a global network dedicated to solving this cosmic puzzle. They are the tools that are taking FRB research from an era of speculation into an era of data-driven science. Beyond solving the riddle of their origin, the latest research is using fast radio bursts as a revolutionary tool to study the universe itself. As an FRB signal gets dispersed as it travels through the sparse plasma that fills the voids between galaxies. With thousands of FRBs detected from all different directions and distances, scientists are now using them to create a three-dimensional map of the otherwise invisible matter that connects galaxies. For years, cosmologists have been puzzled by the missing baryon problem. Our theories of the Big Bang predict how much baryonic matter should exist in the universe, but when we counted up all the matter in galaxies, we could only find about half of it. Using the dispersion of FRBs, scientists have now definitively located this missing matter. It is hiding in the tenuous hot plasma of the cosmic web, exactly where theories predicted it would be. We have journeyed across billions of light years, from the catastrophic quakes on magnetars to the speculative beacons of advanced alien civilizations. The story of fast radio bursts is a perfect illustration of science in action. The central question remains, what is sending these powerful, fleeting messages from the depths of the cosmos? The answer, it seems, is not a simple one. The future of FRB research is brighter than ever. The next generation of telescopes, like the Square Kilometre Array currently being built in Australia and South Africa, will push our capabilities to an entirely new level. Perhaps the solution is something we haven't even thought of yet, a new type of star, or a novel physical phenomenon that will once again rewrite our textbooks. So, the next time you look up at the night sky, remember that it is not silent. It is alive with whispers, shouts, and flashes of light that have traveled for billions of years to reach us. We are standing on the shore of the cosmic ocean, deciphering the messages washing up on our beach. Whether they tell us about the secret lives of dead stars or of the existence of other minds, the answer will undoubtedly change our place in the universe forever. We just have to keep listening.